Hi students, welcome back to Physics for All YouTube channel. Today I am going to explain you about interference in thin film by reflection. In this concept, we have to derive conditions for the bright fringe and dark fringe. To get these conditions, consider a thin film. For this thin film, T is the thickness and mu its refractive index. Consider a monochromatic light. From that light, a light ray AB is incident on the upper surface of the thin film. This incident light AB, some part is reflected direction of BE, which is called as ray 1. Other part of the incident light refracted direction of BC. Again, this ray BC get reflected from the lower surface in the direction of CD. Finally, this ray CD again get refracted direction of df. Finally, we are going to get ray 2 and ray 1. Ray 1 is from the reflection from the upper surface and ray 2 reflection from the lower surface. This ray 1 and ray 2 both are going to superimpose with each other and produce interference phenomena. Now we have to get equations for the bright fringe and dark fringe. In order to get these equations, we have to calculate path difference. Path difference is equal to mu into BC plus CD minus BG. Let us say equation number 1. Now in this equation number 1, to find BC, CD and BG, we have to use the triangles diagram BCD and CDH and finally BDG. In these T triangles, we have to find cos function, sine function and tan function, and substituting this in this equation we can get the path difference. Now we can discuss step by step here. Now to find BC, CD and BG in equation number 1, first of all consider triangle BCH. This is a triangle BCH. Now this triangle BCH we have to find a cos function. Already we know that cos R is equal to adjacent side divided by hypotenuse. The triangle BCH, adjacent side is equal to BH and hypotenuse is equal to BC. Therefore cos R becomes CH divided by BC. Now we need to calculate BC value. So BC is equal to CH divided by cos R. From the diagram, CH is equal to T, nothing but thickness of the thin film. Substitute in the above equation, BC is equal to T divided by cos R, equation number 2. Similarly, we have to find triangle CDH. In this triangle CDH, again find cos R, that is equal to CH divided by CD. CD is equal to CH divided by cos R. Now CH is equal to T from the diagram, that implies CD is equal to T divided by cos R, equation number 3. Now in triangle BDG, BH plus HD is equal to BD. This is called equation number 4. Now to find BD, again use triangle BCH and triangle CDH, then find tan function. So in the triangle BCH, tan R is equal to opposite side divided by adjacent side, that is equal to BH divided by CH. That implies BH is equal to CH into tan R. Now already we know that CH is equal to thickness, that implies BH is equal to T into tan R, equation number 5. Similarly, in the triangle CDH, tan R is equal to opposite side, nothing but HD divided by adjacent side, that is CH. That implies HD is equal to CH into tan R. Now CH is equal to thickness of the thin film. Now HD is equal to T into tan R, equation number 6. Now we have to substitute 5th equation, 6th equation. In equation number 4, we can get a length of BD in the triangle BDG. Therefore, T into tan R plus T into tan R, that is equal to BD. Now, this T tan R and T tan R added with each other, and 2T tan R is equal to BD, equation number 7. Now to find BG in equation number 1, now we have to use triangle BDG. In the triangle BDG, find sine function. So sine I is equal to opposite side divided by hypotenuse. Opposite side is nothing but BG and hypotenuse is BD. Therefore sine I is equal to BG divided by BD. Now cross multiply here, BG is equal to BD into sine I. Now BG is equal to, what is BD? From the equation number 7, BD is equal to 2T into tan R. Substitute in this equation, BG is equal to 2 tan R into sin I, equation number 8. According to the Snell's law, mu is equal to sin I divided by sin R. Sin I is equal to mu into sin R, equation number 9. Now substitute 9th equation in the 8th equation, that is BG is equal to 2T into tan R into mu into sin I, equation number 10. Now substitute second equation, that is BC value, third equation CD value, and BG from equation number 10. In the equation number 1 we can get path difference is equal to mu into BC plus CD minus BG. The place of BC, substituting second equation, that is T divided by cos R, plus the place of CD, substitute third equation, that is T divided by cos R, minus the case of BG, substitute equation number 10, that is 2T into tan R mu sin R. Now in this equation, cos R take as LCM and becomes cos R is LCM, and T plus T becomes 2T. Finally we are writing here 2 mu T divided by cos R minus 2 mu T into, in the case of tan R, I am writing sin R divided by cos R into sin R. In this equation, so here cos R and cos R is LCM, so 2 mu T divided by cos R minus 2 mu T into sin R becomes sin square R divided by cos R. First term and second term, LCM is the cos R. Now take cos R is the LCM, 2 mu T minus 2 mu T sin square R divided by cos R, that is equal to, take 2 mu T as common factor here, 2 mu T into 1 minus sin square R divided by cos R. Now in this equation, 1 minus sin square R can be written as cos square R. This equation can be written as 2 mu T into cos square R divided by cos R. Now this cos R and cos square R going to become cancel with each other, and the balance equation is 2 mu T into cos R, equation number 11. But at the point B, ray 1 makes additional path difference of lambda by 2. Therefore total path difference between the ray 1 and ray 2 is equal to 2 mu T cos R plus lambda by 2. It is a 12th equation. Now using the 12th equation, we have to calculate conditions for the bright fringe and dark fringe. To get condition for the bright fringe, it can be obtained when path difference is equal to the integral multiple of lambda, then ray 1 and ray 2 can produce constructive interference. Because of the constructive interference, it can produce bright fringes. Condition for the bright fringes is equal to 2 mu T cos R plus lambda by 2, that is equal to n lambda. In this equation, send lambda by 2 to right hand side, and 2 mu T cos R is equal to n lambda minus lambda by 2. Take 2 as LCM, and this equation becomes as 2n lambda minus lambda divided by 2, and finally we can write this equation 2 mu T cos R is equal to 2n minus 1 into lambda by 2, where n is equal to 1, 2, 3, 4 and so on. Let us see equation number 13. This equation is used for getting condition for the bright fringes. Similarly, we have to calculate condition for the dark fringe. It can be obtained when total path difference is equal to the half integral multiple of lambda, then ray 1 and ray 2 can produce destructive interference. It results dark fringes. Condition for the dark fringe is equal to 2 mu t cos r plus lambda by 2 is equal to 2n plus 1 into lambda by 2. Again in this equation, this lambda by 2 goes to right hand side and it becomes as 2 mu t cos r is equal to 2n plus 1 lambda by 2 minus lambda by 2. The first term, second term, lambda by 2 is a common factor. So remaining part is 2n plus 1 minus 1. Here plus 1 and minus 1 going to cancel with each other and the balance is 2n. 2 going to cancel and the balance is n lambda. Finally, 2 mu 2 cos r is equal to n lambda. Equation number 4 where n is equal to 0, 1, 2, 3 and so on. This is a condition for the dark fringe. So this is a total question which is called as interference in thin film. So 2 mu t cos r is equal to n lambda where n is equal to 0, 1, 2, 3 and so on. These conditions are important for the short answer question and total concept is important for the essay question. Thank you, my dear students.